So the reciprocal functions and Pythagorean identity. You'll need to remember these reciprocal functions. So sec is 1 on cos, cosec is 1 on sine, cot is cos on sine, cot can also be 1 on tan, and tan is 1 on cot. Find the exact values of each of the following. So this one here will just be 1 over cos of 2 pi on 3. Now 2 pi on 3 is in the second quadrant, and cos in the second quadrant is negative, so this will be 1 divided by negative cos, and of course it will be pi on 3, which means it is 1 divided by negative a half, which means it will be negative 2. Part B, this is cos of 5 pi on 4 divided by the sine of 5 pi on 4, which means it will be negative cos of pi on 4 and negative sine of pi on 4, which means it's just going to be positive, and it's going to be 1 on the square root of 2 times the square root of 2 over 1, which means we're going to get 1. Now this will be equal to 1 divided by negative sine of pi on 4, being in the fourth quadrant, sine is negative, which will be negative 1 on the square root of 2, which means it's going to be negative the square root of 2. Find the exact value. So again, we've got to use the rules. So 1 divided by cos x equals negative 2. Let's flip it. So cos x will equal negative a half, which is that. Base angle, if we work out our base angle, we're going to get, where is cos negative? Well, cos is negative in there and in there. Therefore, cos x will equal a half, gives me x equals pi over 3. That's my base angle. X degrees will equal pi minus pi on 3 to get to the second quadrant, and pi plus pi on 3 to get to the third quadrant, which means I have 2 pi on 3 and 4 pi on 3. Part B, I get tan x equals negative 1. Base angle, we're going to get pi on 4, so that means x will equal pi minus pi on 4, because tan is negative in there and in there, so second and fourth, and we're going to get 2 pi minus pi on 4, which means x equals 3 pi on 4, and 8 minus 1, 7 pi over 4. You can do it on your calculator, so that's how you do it on your calculator. You can follow the steps yourself. This is a rule that you're going to need to remember. Cos squared theta plus sine squared theta equals 1. Okay, if cosec x is 7 on 4, find cos x. Well, cosec x is 7 on 4. We know that cosec is 1 on sine of x equals 7 on 4. Therefore, sine x will equal 4 on 7. Because I have to find cos, I can use the rule sine squared x plus cos squared x equals 1. This is 4 on 7 squared plus cos squared x equals 1. So I get cos squared x equals 1 minus 16 on 49, which ends up giving me 33 on 49. And therefore, if I square root, I get cos x equals plus and minus the square root of 33 on 7. For B, this is 1 over cos x equals negative 3 on 2. Again, using the rule, well, I better flip it first. Cos x equals negative 2/3 sine squared x plus cos squared x equals negative equals 1. Get rid of that, equals 1. So I get sine squared x will equal 1 minus 2 squared is 4, 3 squared is 9, which will give me 5 over 9. So therefore sine x will equal plus and minus the square root of 5 over 3. But we want it in the second ST, we want it in the second quadrant between pi and 2 and pi, and sine in the second quadrant is positive. Therefore we get sine x equals the square root of 5 on 3 only. We don't need to worry about the other one. Example 8, sine theta equals 3 on 5. Theta's between that, find cos and tan. So straight away I'm going to use the rule, which says cos squared theta plus sine squared theta equals 1. Doesn't matter if it's x or theta. So I got cos squared theta plus 9 on 25 equals 1 after I square it. So cos squared theta equals 1 minus 9 on 25. So cos squared theta will equal 16 on 25. Now in the second quadrant there, cos is negative, so this will just equal cos theta will equal negative 4 on 5. Now tan theta is just sine theta divided by cos theta. Sine theta we know it's 3/5 times negative 5 on 4. I'll flip them, so they cancel and I'll get negative 3/4 there. Example number 9. If that, we've got to prove it, so let's start with the left hand side, which equals 1 divided by 1 minus cos theta plus 1 divided by 1 plus cos theta, which will give me, same denominator, 1 plus cos theta plus 1 minus cos theta over 1 minus cos theta, 1 plus cos theta. The cos thetas cancel, as we know, so we're going to get 2 over, this will be 1 squared, which is 1 minus cos squared theta, which just equals sine squared theta, so that's 2 over sine squared theta, and we know that's 1 on sine squared theta is cosec squared theta, so this is 2 cosec squared theta, which equals the right hand side.